This lesson is about calling and returning from methods. A method is a named block of code that may or may not require arguments to be passed to it and may or may not provide a return value to its caller. This is an example of a method that does not accept arguments and does not have a return value. When you call the method, it just prints one line of text and returns to you. You can tell it doesn't require any arguments to be passed to it because there's nothing in the parentheses. You can also tell it doesn't return anything to its caller because it's declared as void. Every method returns to its caller. The only way to have a method not return to its caller is to have the program halt inside the method. If you don't include a return statement, the Java compiler inserts one for you at the bottom of the method. Some people like to include a return statement in every method, but it's sort of a tradition not to put a specific return statement at the bottom of a void method. Here is an example of a method with a return value. The method is declared as an int type, so you know the type of data that it will return. To return a value, simply put the value or an expression that calculates the value on a return statement. If you choose, you can leave off the parentheses. I like to put them on there, but the choice is yours. Java doesn't require them. Here is a method that both accepts an argument and returns a value. In this case, the value returned is the value of the argument multiplied by 3. The full name of a method includes the list of types of its arguments. In this example, the full name of the method is actually total int. This method simply returns the sum of the two argument values passed to it. Here is another method that looks like it has the same name, but it really doesn't. Where the first method is named something like total int, the second one is named something like total int, and it returns the sum of 3 values. When you put in code to call a method, the compiler looks at the arguments you provide for it to determine the actual method that gets called. In this example, the value stored in result 1 is calculated by a call to the first method, and the value stored in result 2 is calculated by the second method. This is called overloading. If two methods have the same name and only differ by their argument types, then the method names are said to be overloaded. It's done a lot, and you'll soon see where it comes in handy. The same thing is done with object types. That is, one method may require a rectangle object, while another method with the same name requires a string type. That's about it for methods. A class can contain dozens or even hundreds of methods. Oh, and calls to methods that pass arguments will also do automatic widening if necessary. That is, if you have a method defined that requires an int value and you pass it a short, as long as there is no method that requires a short, Java will widen the short to an int and call the method for you. Methods that have the same name as the class are called constructors, and they're kind of special. We'll be getting to those shortly. This lesson describes the fundamentals of inheritance. Inheritance is the basis of all object-oriented programming. While this lesson describes inheritance in terms of Java classes, the same basic concepts apply to all modern programming languages. It's all based on classes and objects. As an example, let's start with a class that is so simple it's pretty useless. The class named Figure has one data item and one method. All you can do with an object of this class is to call the getArea method and have it return the value of area, and the value will always be 0. Notice that the area variable is declared outside of a method, which makes it accessible to every method in the class. You could add a bunch of methods to this class and have them all read or write area information. But we're not going to do that. We're going to do something else with it. By extending the Figure class into a new class called Square, we're able to get everything that the Figure class has and add some things to it. That is, we extend the Figure class and add some data and some methods to create a new class called Square. Notice that this class adds a new data item named side to hold the length of a side of the square. The method getSide can be called to return the length of a side, and the method setSide can be called to change the length of a side. Notice also that in setSide, the value of the area is updated to contain the area of the square. The variable named area is inherited from the figure class. The getArea method is also inherited. Let me show you. This class has a main method, so it can be run from the command line. To begin with, it creates a square object and sets the sides to 250. The length of the sides and the area of the square are printed. Notice that the call to getArea doesn't require anything special. It's right there in the square class because it was inherited from the figure class. You can think of a class definition as a blueprint, and you can think of an object as something that is built from the blueprint. For example, once you have a working blueprint of a house, you can build lots of houses from the same plan. That's the same principle as classes and objects. Here is the construction of another square object from the square class. Once you've written a class, you can create as many objects as you like. This one has its sides set to 17, and the program displays each side and the area of the square. When you run the program, it looks like this. Now here is another class that extends the figure class. This is the circle class. It can extend the figure class because a circle also has an area. To make it a circle, however, it was necessary to add a data item to hold the radius of the circle. This implies the addition of a getRadius method, and it's a simple matter to add a getDiameter method. The setRadius method updates the radius value and then updates the inherited area value to match it. Now we have our circle class and we can create objects from it. For example, this class has a main method that creates a circle object and sets its radius to 100, then displays its radius, diameter, and area. When you run the program, the output looks like this. Now this could go on and on. We could make rectangles, pentagons, triangles, hexagoogleton, or anything else we can imagine. The point is, we have a class that can be used as the basis of construction of other classes. Of course, most base classes have more to them than this simple example, but you can see how it works. You can imagine a situation where a base class is complicated enough that extending it to make new classes would save a lot of work. The class being extended is called the base class or the superclass. The class doing the extending is usually called the subclass. Sometimes the process of extending a class is called subclassing. This whole process is what is known in object-oriented programming talk as inheritance, because the subclass always inherits the goodies defined in the superclass. Just about everything in object-oriented programming is the bookkeeping that goes along with creating subclasses from superclasses. Inheritance is the key to all the mysteries. Once you have inheritance clear in your mind, the rest of the mysteries are trivial. We'll be going into constructors and polymorphism, but it's all just bookkeeping that goes along with the same stuff. Let me offer to answer your questions. If there's something in this course that confuses you, please feel free to put a question on the Java forum. If there is something in this course that you don't understand, that's my fault, so please feel free to ask a question. Any question. Let me tell you what happens. You're going along, following me through the examples, and bang, I say something that either doesn't make sense to you or isn't quite clear, or maybe it's just incomplete. If you don't clear up that point, it makes the next thing you study a bit fuzzy, and then the next, and the next. First thing you know, the whole thing's fouled up, and it could be because I just left something out or said it wrong. Please ask. Anything's fair game. If it's about Java, I will answer the question. I check in with the forum once a day. Oh, and there are no stupid questions. If you're embarrassed by your question, do it anonymously. Log in as Moose Breath or something, and nobody will know it's you. By the way, for some strange reason, I really enjoy answering questions, so please ask something. Sun provides a good deal of documentation on Java. You can find it on the same website you use to download the Java compiler. I can't give you the exact link to it here because they shuffle their web pages from time to time. But if you go to this Beluga Lake website, you'll find a link to the download of the latest version of Java, and in that location, you'll also find a link to the documentation. You can view the documentation online, or you can download it to your machine. If you do elect to download the documentation and install it on your computer, it's easy to do. It comes as a zip file, and all you have to do is select the place you want to put it and unzip the file. It will create a directory named Docs and put all the documentation in it and in a subdirectory of it. Just aim your browser at index.html and you're in business. I always download the documentation and I install it in the directory with the Java compiler. The advantage of downloading your own copy is that the web browser responds much faster when you bring up a page, and if you're on a dial-up link, that's a double blessing. I'm also providing you with an email address that you can use in the maintenance of that website. If you find a link on the website that is wrong or no longer active or whatever, let me know at this email address and I'll fix it. I check the links from time to time, but sometimes I make changes before I see them. Now let's look at the documentation. This is the main page of the documentation. This is the documentation for the Java version 1.4.2. Now the format will vary a bit from one version to the next, but it's fundamentally the same. As you can see, there's quite a bit to choose from. Even with all the documentation you've downloaded to your own system, some of these links are to the Java website. But the most used portion of the documentation is this, the API. The letters API stand for Application Programmer Interface. This is the documentation of all the classes and interfaces that are included with standard Java. And there are lots of them. Here on the left is an alphabetical list of the names of all the classes and the interfaces. I know we haven't discussed interfaces just yet, but that'll be coming up soon when we start tracking the mouse. Let's take a look at the Frame class. You'll recall that we've been extending the Frame class to create the top-level window for our applications. You can see here that the Frame extends Window, which in turn extends Container, which extends Component, which extends the base of all Java classes, Object. The Component class contains all the things necessary for something that displays itself on the screen, such as the ability to respond to the mouse and keyboard, and information about sizing and positioning. We're going to be doing a lot with components very soon. The Container class is a special component that is capable of containing other components. The Window class is a blank window displayed inside the frame that creates an area that is usually completely or partially filled with other components. The Frame class itself adds the frame around the window that provides the control buttons and the system menu. The Frame class even has one subclass called JFrame. JFrame is part of what is known as the swing system, which is a set of windows and components that have some special interface techniques. The documentation continues with a description of the Frame class and how it works. The description of some classes is better than others, but there is always an attempt made to describe what a class does and something about how it works. The notation under since tells us the age of the class. The Frame class has been a part of Java since version 1.0. You can also have some links to similar classes or more detailed documentation to help you understand this one. These are the nested classes. There are other classes that are defined inside the frame class. This is something else we haven't covered yet. Next is a list of the publicly available variables and constants. Remember how earlier we used the font class's bold and italic values? They were defined this way. With the frame class, all of these definitions are values used to indicate the status of the window or the cursor. As you can see, not all of the fields that are part of the frame class are defined inside the frame class. Several are inherited from superclasses, and some are inherited from the implemented interfaces. You may recall there were several different ways to create a color object. As you can see here, there is more than one way to construct a frame object. These are the constructors of the class, and we'll be getting to those in an upcoming lesson. Next is an alphabetical listing of all the methods. The name of each method is a link to a full description of the method that explains what the method does, what, if any, values are passed to it, and what, if any, values it returns. And finally, we have a complete list of all of the methods inherited from other classes. As you can see, most of the methods that exist in the frame class are not actually defined in the frame class. In particular, the component class provides a lot of methods to the frame class. That's a quick look at the API documentation of a class. You will find as you go along that you will need to come here from time to time to figure out how to give commands to an object. And this is not a bad place to browse around. I'd suggest that you start with some classes you've already worked with, such as the color class and the font class. Look through those and through some others to get familiar with how the documentation is formed. I promise you, you'll find the API reference very handy. Using the new keyword to construct a new object from a class is known in object-oriented talk as instantiating the class. That is, you're creating an instance of the class, and that instance exists in the form of an object. There is only one way to create an object in Java, and that is to use the new keyword. Every object you encounter in a program, no matter where it seems to come from, was at some point created by using the new command. You probably remember an example similar to this form in a previous lesson. Here, the Java virtual machine loads the class file and executes the main method. At this time, there is no object. The main method, being static, has been fully realized by the compiler and has been sitting in the class file just waiting for something like this to happen. Notice, however, that inside the main method there is a new statement. This statement creates an object from the class and stores the address of the new object in a reference. The very first thing that the new statement does to create the object is to allocate memory necessary to hold it. In this block of allocated memory is a place to store the string reference named quick. The rest of the allocated memory is internal stuff for bookkeeping and the like. The only thing peculiar to this particular object is that space has been allocated for the string reference. The first thing the constructor does is create a string object and store it in the reference. Recall that every variable declared within a class but outside of any method is available to every method of the class. However, it is not available from the main method because it did not exist when the main method started executing. It only began to exist when the main method executed the new command to create the object that holds it. If the string reference named quick had been declared as static, then the main method would have been able to access it because it would have existed in the class just as the main method does. However, if the string reference were declared as static, there would only be one of them, and they would all be accessed from every object created from the class. Here is a modification of the program that shows how more than one constructor can be employed. This is basically the same program, but with two constructors, and with the code to display the window set off in a method of its own named showWindow. The first constructor is just like the one in the previous example. It stores a string in the reference named quick and then displays the window, this time by calling a method. The second constructor accepts a string as an argument, which it stores in the reference, and then calls the method to display the window. The label object is constructed with whatever string has been stored in the string reference. Now the main method creates two objects. The first new statement creates an object by not specifying the string. This causes the first constructor to execute, storing the default string into the quick reference. The second new statement specifies a string as an argument, and that causes the second constructor to execute, and the specified string is displayed in the window. When the program is run, this is what happens. Two windows are displayed because two objects of the same class are created, but each class is its own independent agent and has its own set of data. This lesson will round out the things you need to know about constructors. If you remember the figure class from earlier, it was a class defined without a constructor. It looks like this. When you write a class this way without a constructor, the Java compiler inserts a constructor for you. It doesn't do anything to initialize the object, but it does fulfill the requirement that a class must have a constructor. It's known as the default constructor, and it's just as if you had written the class this way. The default constructor is always created for you unless you provide a constructor of your own. Now let's look at the circle class that extends the figure class. The code isn't shown here, but the constructor of the circle class includes code that executes the constructor of the figure class. The code is automatically inserted by the compiler. You can insert the code yourself this way. A call to super is a call to the constructor of the super class. You can insert calls to super only as the first line of code in a constructor. The compiler doesn't allow it anywhere else. In this example, no arguments were passed to the constructor, so the default constructor is called, whether it was the one you wrote or the one that was automatically generated. Okay, let's look at what happens when a class has more than one constructor. Here's a new version of the figure class that has more than one constructor. This is the same as the previous version, except this one has two constructors. The first one, the one with no arguments defined for it, is still known as the default constructor. It's called that precisely because it doesn't require any arguments. It creates a version of the object with all the default values in place. Using the other constructor makes it possible to create the object and set the area at the same time. We can extend the Figure 2 class like this. Here we have a class with a constructor that requires an argument and uses that value to set both the radius and the area. What is actually happening here is that the default constructor of the superclass is being called, which initializes the area to 0, like this. The call to super is inserted by the compiler, but things can be shortened a bit by using the other constructor of Figure 2, like this. In this form, the area information is calculated and used to make a call to the constructor of Figure 2 that accepts the area information. You could always use super this way to select whichever constructor you prefer from the super class. Oh yes, I need to mention one more thing. The Circle 2 class does not have a default constructor. Because a constructor is provided in the source code, the compiler does not insert a default constructor. A Circle 2 object cannot be constructed without a radius value being specified. You've probably noticed the use of such words as private and public in some of the example programs. These keywords control what is known as access. There is one more of these keywords, protected, and they all have to do with specifying the access that you allow to parts of your class. Some things are accessible only from within the class in which it is declared. Other things are accessible only from within the class and all of its subclasses. Other things are available among all the classes in a package. A package is made up of all the classes that are in the same directory. Packages are also handy when it comes to locating classes using the import statement. If you don't use one of the keywords to specify access, the default is for the item to be accessible to all the other members of the package. That is, it is said to have package level access. Let's look at each access level. Anything declared using the private keyword is limited to the class in which it is declared. If you declare a method or a data item as private, it can only be accessed from methods defined inside that same class. Anything declared as private is not inherited by subclasses extending the class in which it is declared. The private method or data item is strictly private to that one class and can only be accessed externally through non-private methods of the class. Anything declared without an access being specified has package access and can be accessed from outside the class by any other class within the same package. That is, it can be accessed by any class inside the same directory. Now, this includes classes that extend the class as long as the extending class is in the same directory. Using the protected keyword limits access to the class in which it is defined and to its subclasses. It's sort of like specifying something as private but allowing access by all the subclasses no matter what directory they're in. This keyword awards permission of the class member to every class that has access to an object of the class. The data item or method that is declared as public access can be addressed directly by name from anywhere. Classes can be allowed to default to package access or declared as public. You can have as many package access classes as you wish in a single source file, and the class can be used by any other class within that same directory. There can only be one class defined as public in a file. You're not required to specify a public class. All the classes in a file can have package access, but the name of a public class must be the same as the name of the source file. This class naming convention may seem a bit restrictive at first, but after you work with the packages and import statements for a bit, you begin to see the sense of it. It is the import statement that you use to locate classes defined in another package. The import statement is required when you want to access a public class file from another package. The name on the import statement is the full package name, which includes the path name of the directory after which the package is named. For example, the rectangle class is a member of the AWT package, which is a subpackage of the package named Java. The Java package and its subpackages contain most of the classes that are provided as part of the standard Java installation. To provide access to all public classes in a package, you can specify the import statement this way. The asterisk isn't like a wildcard character in the sense that it looks through a list of names. It doesn't do that. It works like this. If you use a name in your program and you haven't defined that name anywhere, Java will try to figure out what the name means by looking for a class file by that name in the current directory. Next, it will look through the import statements to see if it can find an exact match for the name there. If it can't, it will take the import statements with an asterisk on the end and put the name in place of the asterisk to try to construct the full path name of the class. If that fails, it gives up and tells you that the name is unresolved, which is compiler talk, for it couldn't find it. So that's all the asterisk does. It doesn't look up anything. It's just used by the compiler to construct names, and then the compiler looks it up. The difference may seem unimportant right now, but I promise you that you will come across a situation where it makes a difference.